All right, for this video, we're going to get into the three application problems I spoke about yesterday. So in order to write an absolute value equation given a word problem, such as these that are listed below, you can still go with x minus the midpoint. The absolute value of x minus the midpoint equals the distance from the midpoint. However, the midpoint is not really a good term to use when you're talking about absolute value application problems. So I'm going to go with, instead of midpoint, I want you to write x minus the normal range. So whatever is normal for whatever it's speaking of, if it's talking about the bridge, I'm talking about the normal length of the bridge. If it's talking about a valve, the normal width of the valve. Okay. So x minus the normal range equals the change from the normal range. Instead of distance from the normal range, I'm gonna go with, instead of distance from the midpoint, I'm gonna go with change from the normal range, okay? So this kind of works better when you're talking about real life application problems instead of using midpoint. So we'll go with that one that I did in green. So let's take a look at A. It says Sydney Harbour Bridge in Australia is 1,149 meters long. Because of changes in temperature, the bridge can expand or it can contract as much as 420 millimeters. You're going to write and you're going to solve an absolute value equation that will allow you to find the maximum and the minimum lengths of the bridge. So I know you all can tell me, well, it'll go up by 420 millimeters or it will go either down. The normal length of the bridge will go down by 420 millimeters. Well, before we even start, I need you to notice that the normal length of the bridge is in terms of meters, but the change is in terms of millimeters, okay? I don't want to put equal. I'm going to put versus because they're not the same. I need to get the units to be the same. So before I even try to work it, I need to change meters to millimeters or millimeters to meters. All right, so what I'm going to do is I'm going to stick with the unit for the normal length of the bridge. So therefore, I want the change to be in meters then. All right, so guys, I need you to know that 1 meter is the same as 1,000 tiny millimeters, okay? So 1 meter, so you can put this in perspective. If you'll look at my door in the classroom, 1 meter is going to be about the length from my floor to my doorknob. So my floor to my doorknob is about 1 meter. Or if we didn't want to use the term meter, we could say, or the unit meter, we could say it's about 1,000 millimeters from my floor to my doorknob, okay? So if you know there are 1,000 of these and one of those, what can I do to change? Let's figure out how many millimeters are in a meter. Okay. So you know 420 millimeters is a whole lot less than 1,000 millimeters. So we're going to be looking for a number that's a lot smaller than the number 1. Therefore, we're going to be looking for a decimal. So what do? All we need to do is take our millimeters and divide it by how many millimeters we have in all in 1 meter. And that's going to change it to meters. So divide it by 1,000 meters. And we will get 4,200 meters. So which means the bridge can either, when it says expand or contract, it can increase 42 hundredths of a meter, or it can decrease 42 hundredths of a meter. So this represents your change from the normal range, okay? I'm going to go ahead and set the equation up because it asks for the equation first. So I'm going to write x The absolute value of x minus my normal range. Well, what is the normal length of the bridge? Well, the bridge is normally 1,149 meters. Okay, equals to the change from the normal range. Well, it can change by 4,200 meters, and it can go either way. It can either go up or down. So when I get ready to solve this, I still solve it the same way. I said it take the inside and set it equal to a positive version of 4,200s and a negative version of 4,200s. And if I set it equal to a positive version of 4,200s, it will help me figure out one of these, either the maximum or the minimum. Okay. So I'm going to do the positive, but just keep in mind, if you do the positive and you add 1,149 into this 4,200s, that's actually going to give you the minimum, guys. If you set it equal to the negative, you're going to have to end up subtracting, and it's going to reduce this number. So that's going to give you the minimum. But let's go ahead and set it up. Equation 1 will be x minus 1,149 equals to 4,200. That's going to give you your maximum, guys, because we're going to end up adding 1,149 on both sides. And I know normally when we add decimals, we line them up, but we're going to use some common sense. If you have $1,149 and you add 42 cents to it, you get 1,149.42. Okay, and I need to put this in terms of meters. Now, that's not the only thing. This is going to give me the maximum length. I need the minimum length. So I'm going to set up the second equation from this. I'm going to take the inside, and instead of setting it equal to the positive version, I'm going to set it equal to the negative version. And I don't feel like I'm going to have enough room. So let's see what I can do. Yeah, because I'm not going to have enough room there. I'm going to go below here. X minus 1,149 equals to negative 4,200. All right, so if I add 1,149 to both sides, all right, think about this in terms of money. If you take 42 cents from $1,149, you're going to end up with $1,148.52. Excuse me, 58 cents. Okay, y'all hold on just a second, okay? I'm sorry. If you get confused on that, y'all give me a second. If you get confused on that, just set up the subtraction problem. All right. I'm back. Sorry, guys. If you set the subtraction problem up, you know that the decimal is at the end of 1,149. And then your 42 cents or your 0.4200s, and you just subtract from there, filling empty spaces with 0. That's going to become a 10, which becomes a 9, so that can become a 10. That's 8, 5, 8, 4, and 1, 1. Okay, same thing, but put it in terms of, I left the meters off, meters, and that's going to give you your minimum length. All right, let's take a look at B. You all, hold on just a second. I hear somebody at my door. Hold on just a second, guys. Sorry about that. All right, let's take a look at B. The diameter of a valve for the space shuttle must be within 1,000th millimeters of 5 millimeters. So your diameter is the distance all the way across a circle. So if I have a circle here, and it's the opening of a valve, and I say that, and it has to go through the center, that my valve has a diameter of 5 millimeters, guys. So normally the valve has a diameter of 5 millimeters. But it says it has to be within 1,000 millimeter or 5 meters. So this is the normal range for it. But, when we're making things, sometimes we don't always end up exact. So there is some margin of error that you can use here. If you're within 1,000 millimeters, you can be 1,000 millimeter above 5, or you can be 1,000 millimeter below 5. 1,000 millimeter below 5. All right, so we're going to write and solve an equation to find the boundary values for the acceptable diameter of the valve. Remember, it has to be within that distance of the normal range of 5. So since 5 is acting as our normal range, we write x minus 5 equals 2, and then the change. Well, it could change by 1,000 millimeters. That's the change. So it has to be within that distance from 5, either above it or below it. But that's the only leeway that's allowed when you're talking about space shuttle valves. Okay, you want to make sure you stay alive and nothing blows. Everything needs to stay intact. All right, so that's my equation, and then I'm going to solve. This is pretty simple. Okay, so solve. You're going to take the inside, x minus 5, and set it equal to 1,000. And then you're going to take the inside, x minus 5, and set it equal to negative 1,000. Now you can set these, when you add 5 to both sides, you can add 0, 0, 0 if you want to. But to me, it's not necessary. 5 plus 1,000 is 5 and 1,000. Okay? And let's put it in terms of millimeters. So that's the greatest diameter that a space shuttle valve can have. Okay, what is the smallest diameter that it can have? So I can get rid of that minus 5 with plus 5. And I know the bigger number is not on top. But guys, if you need to put the bigger number on top and subtract, go for it. But if I take 1,000th away from 5, I'm going to end up with this, guys. 999 thousandths. But if you need to, and let's put millimeters. If you need to, please put your 5 on the top and subtract your 1,000 if that's what you need to do. Go for it. That's a 10, which then becomes a 9. That's a 10, which then becomes a 9, and that becomes a 10. So 9, 9, 9, and 4. You'll still get it. All right, so these are the acceptable values. It can be anywhere from 4 and 99 hundredths meters up to 5 and, not 99 hundredths, 4 and 999 thousandths millimeters up to 5 and 1,000th millimeters. Okay, this one we got to be able to use percents. So let me tell you something, guys, about percents. If you want to find a certain percent of a number, before we even start, I need you to know this. You're going to change a percent to a decimal. You're going to change it to its decimal version, and you're going to multiply by the number. So your percent gets changed to a decimal version. To change a percent to a decimal, you slide the decimal two places left and drop the percent. And then all you do is take that decimal and multiply by the number that you're trying to find the percent of, okay? For instance, let me give you an example. For instance, if I'm trying to find 10% of 50, all I do is drop the percent, move this decimal two places to the left. So that's 0.10 or 0.1, and it's going to be times 50, and you would get 5. That's all you would do. Okay, so we should understand how to change a percent to a decimal and then find a percent of a number. Change a percent to a decimal, I'm moving 2 places to the left and dropping the percent, and then multiplying that decimal by the number you're trying to find the percent of. Okay, now let's look at C. It says, a brick company guarantees to fill a contractor's order to within 5% accuracy. Okay, so they're not, you imagine trying to put bricks on the back of a truck and haul them off to somebody's, I don't know, property so they can build something. Like, who's going to sit there and count everyone and then think you're going to be exact for all the bricks? It might be some mistakes there. So they're saying, well, if the contractor orders 1,500 bricks, then you may get a little less than 1,500, or you may get a little more than 1,500. Just letting you know, the count may not be exact. Okay, so that's why they have within 5% accuracy. But what the person would normally want is 1,500 bricks if that's what they ordered. Who wouldn't want differently? If that's what you order, that's what you order. So write and solve an absolute value equation to find the maximum and minimum number of bricks guaranteed. Okay, so what I need to do, first of all, is figure out what's 5% of this 1,500. So what's this within 5% accuracy talking about? Well, within 5% of 1,500. Well, that's question one. What is 5% of 1,500? So I can figure out exactly how many bricks you may be short or how many bricks you may be over. So what I'm going to do is drop the percent on the 5 and move the decimal 2 places to the left. And I'm going to multiply 0 and 500s times 1,500s. Or 1,500, sorry. So we'll multiply that out. All right, so we have 1,500 times 0.05. That's going to be 75 bricks, guys. So when it says within 5% accuracy, I already know that when I order from this company, they may give me 75 bricks more or 75 bricks less. And it's in the contract. That's what they're guaranteeing. Okay, they're guaranteeing that they're going to get your order right within 5% accuracy. So they could be short, they could be a little over. But they're going to be within those 75 bricks from your order. Oh my God, guys, I'm sorry. Somebody else. I'm going to ignore it. Okay. All right. Now, let's take a look. I have my normal range is 1,500, so it's the absolute value of x minus 1,500. And how can the bricks change? Well, you may get 1,500 bricks, but you might get 75 less, or you may get 75 more. So the change could be within 75, either way, up or down, above 1,500 or below 1,500. So that's my equation. But I also have to solve it. Okay. All right, so I'm going to solve it. So you have x minus 1,500 equals to 75. And this is going to give me the amount of bricks over, which you should have been able to tell me that anyway. If you're 1,500, if you're 75 bricks over 1,500, you may end up with an order of 1,575 bricks. Or you may not be the lucky person and get 75 bricks over. You may get 75 bricks under. So you would put negative 75. Add your 1,500. So we end up with x equals to 1,425 bricks. You may be 75 bricks short. Now, common sense would tell you subtract 75 from 1,500, even here, you're going to get that, okay? Or if you add 75 to this, you're going to get that. So, yes, I know you can do this problem in your head, but my goal is, can you set the equation up? Okay. Yes, I know you can tell me the answers. 1,575 or 1,425. But can we set these equations up, guys? Remember, these equations are set up in terms of x minus a normal range is equal to the change from the normal range. All right, if that's something you don't understand, guys, I can go back through this in class tomorrow, okay? All right, see if you can work on your homework. Thank you.